So hi, my name is Ben Turchak. I'm a research biologist with Michigan DNR out of the Charlevoix office, but I actually grew up about 15 miles east of here out in the thumb of Michigan. So it's kind of a nice excuse for me to come home and get some home cooking here. So I am co-chair of the Salmonid working group with my co-chair Matt Cornice, who will be presenting a little later. There's a bunch of other members of the Salmonid working group. Some of us are also on a predator-prey ratio modeling subgroup of that committee. That has pretty good representation across the different jurisdictions and agencies that are working on Lake Michigan. So most of you are probably familiar with like the predator-prey ratio that gets presented in various forms each and every year. We don't have the 2023 results done yet. That usually happens a little later in the spring. So I can present the 2022 results this year and also some of the results of our auxiliary indicators, which are often a good sort of a good surrogate or ancillary information for the predator-prey ratio. In a lot of cases, we use them to validate what we're seeing with the predator-prey ratio. So for those of you that may not be familiar, the predator-prey ratio is simply the biomass of Chinook salmon, modeled biomass of Chinook salmon, divided by modeled biomass of alewives. So the top two lines derived from catch-at-age models divided by one another results in the predator-prey ratio. So it's the relative relative availability of prey for those predators. High numbers indicate that there's relatively few prey available for the number of predators that are present, and low numbers indicate that there's lots of prey available for the number of predators in the lake, which is why it's represented in red and green. So the auxiliary indicators that we have kind of fall into a couple different groupings. The first couple are related to the size of Chinook salmon, so that should be an indication of how much food they have available for them to eat on any given year. The indicators 3 and 4 are metrics that are related to catch and catch rates of Chinook salmon and other salmonids, so something about the relative abundance of the salmon in the lake. And the last two indicators are related to the prey, so those are alewives in this particular case. I don't have information on prey readily available to me yet. I think we'll hear more from USGS about those numbers later on this meeting. So I'm going to focus in on these first two, which are related to the size of Chinook salmon, and then the second indicators 3 and 4 that are more related to those catch rates and harvest compositions. So starting with this first indicator, this is the standard weight of Chinook salmon at 35 inches from July 1st to August 15th. So first of all, what do I mean by standard weight for those that might not be familiar? Standard weight is simply, I fit a relationship to the length weight curve for Chinook salmon on any given year. That's usually a really nice relationship. There's a strong correlation between length and weight. And then, use that relationship to estimate how large a 35-inch salmon would be on any given year. And so even though these curves all look pretty much the same, if you were to draw a line, vertically up from 35 inches, you just trace it over, and that's the standard weight on any given year. So if you look at that trend through time, broken out by state, there's been a general decreasing trend through the 2000s, periods of like major fluctuation that corresponded to some nice year classes of alewives that were coming through, and then it's been relatively high for the last 5 years. Data from 2023 suggests that there's been a bit of a decline in Michigan and Wisconsin waters. I don't have information for Illinois and Indiana right now, but as those data are added, this will obviously be updated. So all of these results are they're still hot off the presses. There's more information coming, and we'll update it as those data come in. But keep in mind that Michigan and Wisconsin, they usually have the lion's share of the catch, so this is probably not going to change a whole lot. If we were to combine those data together with a weighted average, here again you can see that over the last 5 years we've been near the highest we've seen in almost 2 decades, with the exception of last year. There was a pretty big drop. So that decline would suggest that maybe there's more predators out in the lake relative to the number of prey. So an increase in the predator-prey ratio if you were thinking about it in terms of that predator-prey balance. So the second indicator is the weight of age 3 female Chinook salmon returning to weirs and harbors in the fall. We have 7 locations around Lake Michigan where we get this information. So that these include several locations in Wisconsin, several in Michigan, and then the harbors of Illinois. They generally are corresponding to one another, although in recent years we've seen sort of a departure of the different time series from one another. So if I were to just reduce this down to several primary locations that we have in each of these states, you have the harbors in Illinois, the Little Manistee River, which is our egg take facility in Michigan, and the Strawberry Creek Weir in Wisconsin, which is an egg take facility in Wisconsin. Strawberry Creek tends to always have the largest fish that we see coming back in the fall. Little Manistee River is usually lower than that, and then the weirs in the harbors in Illinois were quite low in terms of the size at age 3 last year. I'm not sure what drove that pattern, but we saw it continue into 2023, where they were much smaller than what we saw at northern sites. One thing to note here is that there was no tagging of Chinook salmon that were stocked at the Little Manistee or Medusa Creek weirs in Michigan in 2020, and as a result, we didn't have known age fish returning to our weirs in 2023. So this is only through 22. We don't have information for known age 3 fish in 2023. So what you're seeing here is a weighted average based on Strawberry Creek and Illinois harbors only, but similar to the standard weight at 35 inches, a bit of a declining trajectory since that record high back in 2018 or 2019. Again, suggesting that there's probably relatively more predators for the number of prey that are out there. So, third indicator, catch per hour for Chinook salmon on charter boats. Top panel, this is the harvest through time, this is effort through time on charter boats, and then this is the harvest rate, or simply this divided by this, and that's those lines. The colors correspond to the different states. I don't think I need to tease out too much here. I want to point out that in general, charter effort is much more stable than sort of recreational effort in general, because charter fishermen are going to go regardless of whether or not the fishing is good. And we've seen some, if I merge these together with weighted averages again, we saw sort of a heyday of Chinook salmon fishing in the early 2000s, and that started falling. A couple good year classes of alewives and an epic 2012 fishing season. Again, effort is shown on a pretty small scale here, so this is actually a relatively constant, line. There's not a lot of variation here, and that's reflected in this catch rate. So here's high catch rates of the early 2000s, that 2012 season, and then it's been declining right up until recent years, and we've seen that catch rate increasing, creeping up in recent years. So all these things seem to be suggesting the same thing. We're seeing smaller size at age, smaller size, at 35 inches, and an increasing catch rate, which suggests that there's probably more salmon out there than what there has been, at least relative to the prey that's available. Final indicator is the percent composition of angler harvested weight by species. So there's 5 primary species of salmonids in Lake Michigan that are represented in these figures, and I'm gonna pare all this down, but I wanted to show you sort of the broken out by the different species in different states through time. Brown trout's been declining. Wisconsin typically has the highest brown trout harvest of any of the states. Chinook salmon, there's again that sort of heyday of harvest in the early 2000s, and then again in 2012. Note the difference in the scales on these. So Chinook salmon is an order of magnitude higher at its peak than what the other species were. It really dominates harvest in Lake Michigan. Coho salmon's fluctuated through time. Recent years, we've seen an uptick in almost all the states in terms of coho salmon harvest, but again, probably at a lower level than what we see for Chinook salmon, which has also increased in recent years. Lake trout, we see a declining trend and an increasing trend, especially in Michigan waters. I'm going to talk more about that in a minute. And steelhead, again, Michigan and Wisconsin tend to dominate steelhead catches, fluctuating back and forth, but Wisconsin in recent years has had a higher steelhead harvest at a little bit lower rate than what we would have seen prior to 2000. Combining those lines together, brown trout harvest has really been going down in recent years. This is a little interesting. I actually expected that to go up this past year because we had some pretty good brown trout harvest early on, but it might have been missed in some of our creel surveys just as a result of sort of the timing of when that fishery happened and when our creel programs started, at least in Michigan. Chinook salmon, there's that uptick at the end of the time series. We've been seeing this increasing trend in Chinook harvest through time. Coho salmon, nice increase at the end of the time series here. and lake trout a pretty substantial decrease in recent years. And I think that decrease might correspond to a couple things. In particular, when salmon fishing is good, which it has been in recent years, folks are going to target those silverfish over lake trout. That we've seen that throughout this time series. So in this sort of peak of Chinook salmon in the mid or early 2000s, we see lake trout go down. So if you were to actually plot these two things against each other, you'd see a pretty strong negative relationship between the two. So as the salmon fishing has gotten better, we've seen a decline in lake trout harvest. That could also be related to the stocking reductions that Laura mentioned as well in the previous talk. Steelhead has been, there's sort of two segments to this. Sort of prior to 2004, harvest was very high. After 2004, we've seen a lower level, but I don't know if you could really say that there's much of a trend here. It's been relatively stable, maybe lower in recent time. Combining all those lines together, you can see sort of the scale that Chinook salmon plays relative to some of these other species. It's roughly 50% of the harvest through much of the time series, and in that sort of peak harvest period in the early 2000s, it might have made up as much as 75% or more of the harvest. And then looking at that on a percent composition basis, like I said, Chinook salmon is about 50% or more. It's been increasing in recent years along with coho salmon, which are shown in green. Lake trout have declined in recent years, and steelhead have sort of been relatively stable. Brown trout almost negligible at the top of that figure. So those are sort of the primary indicators that I wanted to talk about, but I also want to sort of read the crystal ball here and try to guess what the predator-prey ratio is, just to demonstrate sort of the relationship of these different indicators with the predator-prey ratio. And as I mentioned before, it gives us a nice sort of a sanity check when we actually do produce a predator-prey ratio to make sure that things are looking the way we expect them. And so the first is the relationship between the predator-prey ratio and the size of salmon returning to those weirs in the fall. So strong negative relationship, which you'd expect, right? As salmon size gets smaller, it probably means there's less prey available to them, so that predator-prey ratio is getting as the predator-prey ratio gets lower, we're seeing this larger size at age 3. So if we were to use that to then predict, using the 2023 data, predict what the predator-prey ratio is going to be, it's actually a little bit lower, which I was surprised about, but it's because even though the trend is declining, it's still relatively high for the time series. So the fish are still big. They're getting smaller, but they're still big. Same thing with the standard weight at 35 inches, declining trend with the predator-prey ratio, but those fish are still big relative to the long-term, at least the last couple decades. But we see a slight increase in the predator-prey ratio if we were to use that as the predictor. And then using charter catch per effort, adding the 2023 data, and then predicting there, somewhere in the middle. So if I had to guess, I would say the predator-prey ratio is probably not going to be wildly different than what it was in previous years, but we'll see as those data come in. So the last two indicators are lake-wide biomass of alewives and the age structure of the alewife population. I'm going to argue that these two things are both very related to predation mortality on those alewives. So if you get more predators, there's higher predation mortality. That's going to drive biomass down. At the same time, it's also going to truncate age structure to younger fish, right? So fish just aren't going to live to be, those alewives aren't going to live to be 5, 6, 7, 8 years old when there's tons of predation. They're not going to make it that long. So I want to talk a little bit about predation mortality. I'm going to skip past this for the sake of time. But in the early days of salmon stocking, we saw this big increase in predation mortality corresponding to the introduction of Pacific salmonids, the reintroduction of lake trout. And so with that, predation mortality went way up. Then in 1985, it all kind of fell apart, right? So I think most of us probably know what happened here. This was the bacterial kidney disease outbreak. So survival of Chinook salmon completely fell apart during that era, and even though there were lots of fish being stocked in the lake, they just weren't surviving, and so predation mortality fell way down. After the BKD epizootic ended, we saw survival of Chinook salmon go up, and this period corresponds to those really good catch rates in the early 2000s, which, subsequent to that, there were stocking reductions to try to maintain some predator-prey balance, and so we saw predation mortality fall. In recent years, it's been coming back up. So those changes at the end of the time series, I think, are related to management actions. Looking at it a little differently, so here again, it's predation mortality ramping up with those initial stocking years, and biomass was sort of declining during that period of time. And then right here, we see, the biomass of alewives increase. And I think it's worth pointing out here, I'm going to do this, I think, every time to really drive this home. There's one point of time in this entire time series where we see alewife biomass consistently increase. And that corresponds to a predation mortality that is below 0.3. That's during an epizootic event, the bacterial kidney disease outbreak that resulted in really poor survival of Chinook salmon, and that allowed alewives to recover in terms of their biomass. That's also when we saw the oldest alewives present in the lake. So there were some fish that were 5, 6, 7 years old present at that time. Now compare that to more recent times where we've seen much higher catch rates of Chinook salmon, like in the early 2000s, and this continuing decline of alewife biomass over many consecutive years, corresponding to a predation mortality greater than 0.55. So I think we could reasonably guess that somewhere in the middle there's a sweet spot where we might be able to sort of stabilize alewife biomass. All this assuming that recruitment dynamics maintain some kind of stability or baseline. So depending on what our management goal is, these are sort of the targets that you might have. If you want to increase alewife biomass, you'd want to shoot for a predation mortality rate less than 0.3. You want to stabilize it somewhere between 0.3 and 0.55. And if you want to drive alewife biomass down, somewhere above 0.55 is where we want to be. Looking at this again, Chinook salmon biomass at the top, alewife biomass in this panel, the predator-prey ratio, which is, this is the numerator and denominator of this ratio. This is that predation mortality right now, and that green bar is that sweet spot I was just talking about. In 2022, we started creeping up above that line, so we're starting to look like we're at the point where we're going to be pushing alewife biomass down, again, assuming that alewife recruitment remains relatively stable. If there's some major recruitment event, this might be a different story, but it looks like we're on an increasing trend right there that's going to be pushing alewife biomass down in the future. So with that, I think I'll wrap up and hopefully have a little bit of time for questions. This is a link to the predator-prey ratio analysis report that we put out each year. Normally I print this thing out and put it somewhere and nobody picks it up. So if anybody's interested, you can scan the little QR code here and it should download the PDF right to your phone. That's it. That's all I got. Thanks.